All right, for this problem, we're looking at these two statements, trying to see which of them are true. So let's start with the first statement. Looking at the right side of it, this x squared plus y squared, you should know just by looking at that that is something that cannot be factored into something like x minus y squared. I mean, we can prove that this is not true for all real numbers pretty quickly just by giving a couple random values for x and y. For example, let's give x a value of 1 and y a value of 5. So that's x squared plus y squared, right? 1 squared plus 5 squared equals 26. Now, is that the same thing as x minus y squared, which is 1 minus 5 all squared? That would become positive 16. So there's a real quick proof that this is not true for all real numbers. So that rules that one out. Now, to figure out the next one, it may be a little bit trickier, but one way we can work through it algebraically is actually expanding x plus y cubed. Now, if you're familiar with the binomial theorem or Pascal's triangle, that kind of helps you figure this out. But the expanded form of this would be the first term cubed multiplied by the second term, which is y to the power of 0, which, anything to the power of 0 is 1, so ignore it. So x cubed is our first term. Our second term will now be x squared, so it's 1 less than 3, and then y to the power of 1, so we'll just write that as y. Oh, and we can't forget that there's actually going to be 3 of those terms. And moving on, the next term, there will also be 3 of them, and now it's going to be x to the power of 1, y squared, and then finally our last term would be x to the power of 0, so we'll just not write it, and then y to the power of 3. And so you can see our coefficients follow Pascal's triangle there, 1, 3, 3, and 1. So that is the expanded form of x plus 3 all cubed, and we can see that that clearly does not match the statement number 2. So actually, neither of these are true for all real numbers. Therefore, our correct answer is option number 4. All right, hope that was helpful, and thanks for visiting JD's preparation.